babbling. If you think of any like topic or a specific thing you'd like to talk about today, let me know because it's pretty much just a review. Otherwise, I have some material prepared. But if you guys want to talk about anything specific, we can. So your final exam is, of course, the last thing that we have besides this class. So, excuse me. The final exam is Tuesday, December 8th at 4 p.m. So notice the time difference. The university sets those, not me, so there's nothing I can do about it. So it starts at 4. The exam is going to be on Blackboard under the assignment tab. So if you've taken any of the quizzes, it'll be in the same spot. If you haven't, what I'm going to do, I'll put it up today, is I'll put kind of a mock exam there. It's not really for practice. It'll probably just be a bunch of old quiz questions. But just so you can get an idea for the layout of Blackboard stuff if you haven't taken one on Blackboard before. I haven't officially written the exam yet, but I'm planning on it being mainly multiple choice, some true false, and maybe even a matching section. Something that's going to be quick and hopefully actually Blackboard can handle it grading wise because the university kind of expects those to be done quickly. So I want to make sure that they're easy to grade. There will be some free response. Don't think that there's not going to be any of that, but there's ooh, good point. I'll say that in a second. But for the most part, the majority is probably going to be multiple choice, true, false. Short answer, something that's not showing tons of work or anything like that. There will probably be some find the error questions. What I'm probably going to do that's slightly different from what how I've done them before is I'll probably give you the work laid out like I did before, but I'll tell you how many errors there are. And then you just have to find them instead of you just kind of looking blindly. But there will probably be a couple of those. Not too many that will probably need work required with them. There might be some where it's something like a Riemann sum, and I say find a left-hand side, and I'm expecting you to, write out something like 2 times 7 plus 5 plus 4, and then write the final answer instead of just writing the final answer. But anyway, I'll get to those questions in a second. The exam's going to be open note, open resource. So that means anything that's, already out there in the world you can use. So to be very clear, that means you cannot post the exam questions to allow internet strangers to give you the answers. So no posting to Chegg, Reddit, Stack Exchange, whatever else you can think of. You can't post the questions, you can't work with other people, you can't ask people for answers, all that type of jazz. But if you want to look over your lecture notes, if you want to watch a recording again, if you want to Google, all that's fair game. You should not be able to find the actual exact exam questions. I have checked, I will check, and trust me, it's easy to find if people post them. So don't do it. But you won't be able to find the exact questions, but say you Google and you find a very similar question, go right ahead. Use it to help you figure out what the answer is. But you shouldn't be able to find the exact questions. That's kind of the point. But you can use whatever's out there besides other people to work on it. You have 2.5 hours. It's like a 2.5 hour period that the university denotes. And this kind of Oh, that's technically a slightly different question. So there's a 2.5 hour period to take it. I'm going to write approximately an hour and 45-minute exam. Anastasia, in terms of your question, I usually write it to be about a 65-minute exam for you guys because you had 75 minutes. So the way I usually do my exams is I have to take it and then I multiply the amount of time it takes me to take it by 5. And that's how much time you guys get. So usually I had to take the exam in 10 to 12 minutes, and then that would give you guys at least 50, if not 60 minutes to take it. And that's usually a decent place. Most quote unquote average students can do that, 5 times what it takes to take for me to take it kind of deal. Anyway, so I'll attempt to write about an hour and 45-minute exam, so just a little bit longer than your normal exam. So again, that'll mean that a quote unquote average student will be able to take it in approximately an hour and 45 minutes, maybe 2 hours. So you might not need the 2.5 hours, but you'll have it if you need it. If you have documented extra time, I will be pushing that through manually on Blackboard. If you do have documented extra time, do me and you a favor and triple check when you open the exam. So when you open the exam, it should tell you the time limit. And it should even have it at like the top when you're taking it, I think too. If you open it and it still says 2.5 hours and you're supposed to get extra time, close it immediately and email me. Because I'll be pushing those through. I shouldn't forget and I shouldn't screw it up, but just in case something seems wrong and you are supposed to receive extra time and it doesn't look like you are, let me know immediately. I'm going to be on Teams at the exam time. You do not have to be in Teams, okay? You do not have to be here in Teams at all for the exam. You just take it wherever you are at 4. But if you have questions or for some reason you just want to sit and take it on Teams in case you have questions, I will be here twiddling my thumbs for 2.5 hours. The last thing I'll say before I got questions in a second. I'll have some office hours this week. Tomorrow, Wednesday from 12 to 2, and then Thursday from 1:30 to 3:30. So if you guys don't already know or remember, there's classes for the rest of the week. Wednesday, Thursday, Friday are reading days. There's no classes. You just get to study. So I'll be in my office hour team from 12 to 2 tomorrow and 1:30 to 3:30 on Thursday. If you've never been to my office hours team, you essentially just go to the Teams tab on Teams, and there's like a join button in the right corner, and you'll need this code that I'm highlighting down here. I'm also going to put the office hour information up on Blackboard in an announcement in case you forget and want to come by. Okay, that's everything that I wrote on there. Yes, the time frame, in case you're somewhere else, is Eastern Standard Time. So 4 p.m. EST on Tuesday, December 8th, is every topic going to be covered on this exam. If I'm picky with wording, no, because there's just literally not enough time to put a question with every single topic. Every single topic is fair game. For the exam. It's cumulative, it covers everything. I will say that that it's going to be slightly heavier with the exam 2 and exam 3 material, essentially chapter 2 to chapter 6. So chapter 1 material is fair game, will definitely appear on the final, but there will probably be a bit more derivative, antiderivative, integral stuff than there is chapter 1 material, but technically everything is fair game. No, so since there's no classes or anything on Thursday, there's no quiz or anything like that, you guys are done quizzes. The last thing you have for this class besides the final is you have your homework. Your very last homework is due on Thursday. Remember, I pushed that back a couple days because of Thanksgiving. So Thursday, you have that final homework assignment on Wiley. And besides that, it's the last homework assignment, final exam, and then you're rid of me for the rest of your lives. Except I think some of you are taking a class with me next semester. It's pretty cool. Anyway, so a different class, by the way. Anyway, so I don't see anyone that wants to talk about anything specific, so we'll just go over the stuff that I have planned. If at any time you're like, oh, I just remembered this thing. Can we talk about this thing? Let me know. You don't have this. So I'm going to give y'all a couple seconds in case you want to write down the question every once in a while. But this is nowhere in your lives. It's something that I just did for today. I'll post the answers. I can even post a blank copy afterwards I don't know why it would be helpful afterwards, but I'll put it there anyway on Blackboard. While I'm waiting for people to write this down in case they want to write it down. One more thing I'll babble about. The kind of official exam review. Let me triple check that it's there. Oh, there is? Oh, ho, ho. There is a blank copy on Blackboard, apparently. Look at me. Being all, huh. I forgot to put that there. Anyway. Yeah, I'm going to post a completed version of this 100%, definitely. So anyway, the official exam review, because this isn't technically the official, this doesn't cover as much stuff. It's just covering as much as I thought we could get through in one class. The quote unquote official exam review is up on Blackboard in the normal exam spot. Oh, so I gotta say a couple more things about that. So that the answers aren't up yet. I will try to get those up today. Worst case scenario, they'll be up tomorrow. So the answers for the final exam review will be up as soon as I can. I also believe I need to post the answers for exam 2 and exam 3. Yes, I do. So I will scan those in and post those before I leave today. If you want your exam 3 back, shoot me an email and I can scan it to you. Okay, I think that's everything I needed to say. Okay, so here we go. This first question is kind of long. It has a couple parts, but that's because it covers a lot of different questions and a lot of different material. This is kind of going back to chapter 1 stuff, and then towards the end of the question, it gets into a little bit of chapter 2. Anyway, you open a bank account, $5,000, earns 2%. I'm recording, right? Yes, I am. Earns 2% interest annually. Write an equation for the amount you will have after T years. So this is an exponential question. So remember, or reminder, we have two forms for an exponential function. We have P naught AT, or we have P naught e to the KT. And remember, the A is made up of 1 plus R. So it's been a very long time since we've touched on that. And remember, the difference between the two is that this form, the e to the KT form, is used when you see the word continuous. Sorry, apparently I don't know how to breathe. So the e to the KT form is used when the word continuous is in the statement. I'm just going to stop there. If you don't see the word continuous, you have to use the a to the t form. It gets a little more ambiguous than that, but just to be on the safe side, if it doesn't say continuous, just use the a to the t. So here it says annually, which technically does actually mean a to the t, but since it doesn't say continuous, we're in the a to the t situation. So we need an equation of P naught a to the t. So our P naught is our initial value. So we start with our $5,000. And then we're going to find the a value using that 2%. But remember, the percent always needs to be changed over to a decimal. And that gives you your rate. So in this case, it gives us the R value, not the A value. If this was a continuous question, it would go in for K and you wouldn't do anything to it. But here, since it's an A to the T form and R is 0.02, that means that our A value is 1.02. Which means that the equation we were asked to find is going to be 5,000, 1.02 to the T. Then we're asked, how much will you have after 10 years and how long until you have $7,500? So that's kind of two separate questions, so I'm going to break it up a little bit. So how much will you have after 10 years is kind of like just a plug and chug. So we're going to take that 10 years that they're asking us to use and plug it in for T. So we've got 5,000, 1.02 to the 10th, and I actually never wrote down the answers for these, so 0.02 to the 10th is approximately 6,094 point, and since it's money, let's just take two decimal places. But then with the second piece, how long until you have $7,500? So now they don't give us a time, they give us a final amount. So we want to set this equal to 7,500. Well, remember so essentially what we want to solve for is in an exponent. So remember when you have something in an exponent that you want to solve for, this is when we're going to have to use our natural log process, where we have to natural log both sides. But if you remember, before we natural log, we have to get the thing with the exponent by itself. So we need to isolate it, is I think the word that we used when we wrote down that process. So we want to isolate the thing with the exponential. If I can, you don't see it, but there's a thing in my way and it's not moving. Move. There we go. All right, sorry. So we've got to divide both sides by the 5,000. That is 1.5. Now I dropped the parentheses just for personal preference, but you can keep them around if you want. But once I got it by itself, I can kind of make them go away. And now that we have the God, my English is not working. We have the thing with the exponent by itself. We can natural log both sides. So we're going to natural log both sides. So natural log of 1.5. And this is where you can use other natural log bases, other log bases if you know how to use them. So if you wanted to take log base 1.02 and you know how to do that. And remember, the point of that is that we have a rule that tells us that we can bring a power outside of a log, which is nice because once we get there, to solve for t, we now just have to divide by that one natural log of the 1.02. So to get our answer here, we have the natural log of 1.5 divided by the natural log of 0.02. And that is approximately 20.48 years. So it'll take approximately 20 and a half years before you would reach $7,500. Questions, concerns about those pieces before we move on? Okay. So next we're asked to write an equivalent equation for continuous interest, and then we're going to use that for the remainder of the problem. Notice the word that I kind of tried to bold, equivalent. So now that I've scrolled past it, let me write this down again. So we have two different forms. And technically, you can have them as two separate things. So I could just say, what is this equation with continuous interest? And that would just be letting that k value be 0.02. But here, we want the equivalent equation. So that's where we essentially want the equation such that these two are actually the exact same thing. So remember, if we look at these two forms, the only thing that's actually different between the two is the a versus the e to the k. So if we want these two things to be the exact same thing, we would want to let that a be equal to that e to the k. If that happens, then those two things are actually the exact same thing, just different forms. So if we want the equivalent form here, we want to take the equation that we had and find the equivalent state. So the P naught isn't going to change. It doesn't change between the two forms. But we essentially want to let that A value be equal to e to the k. And the k is what we want to solve for. So remember, e is a number. I will never use e as a variable. Almost no mathematician will use e as a variable. So we want to solve for k. So this is another case where we have to take the natural log of both sides. And I'm going to bring the k out at the same time just to save myself a line. And I don't know if I put it. Remember, the natural log of e is 1. So we kind of don't have to think about it because anything times 1 is itself. So the k value is going to be whatever the natural log of 0.02 is. So the natural log of 1.02 is approximately, let's take 4 decimal places here, 0.198. So very close to 0.02, but not quite. And I do want to be clear, with these equivalent ones, it does seem like it often turns out to be a very similar number. The larger the interest, the larger the rate, the larger the gap between the two numbers are going to be. So since 2 is a relatively small number when it comes to interest, those two rates do turn out to be very similar, 0.02 and 0.0198. But don't think that's always going to happen. If the rate is very large, then those two are going to differ by a larger amount. Anyway, so the actual answer to this question is we want the equation. So our P naught didn't change, but now we have e to the k t. And now for the rest of the problem, we're going to use that equation whenever it asks us to use that equation. To use an equation. So the next thing we're asked for is the rate at which the amount in your account is growing. So if it's a rate, we want to think slope, we want to think derivative. So we want the derivative of this equation. And again, we're going to be using this continuous interest equation now. So we want the derivative of that equation. So up to a few days ago, we'd been working with antiderivatives, so we kind of got to switch our brains back to derivatives. So remember, the 5,000 is just going to come along for the ride. Any constant in front of a function just chills. And then we need to take the derivative of e to the 0.0198t. If you want to treat that as an e to the kt rule, go right ahead. I'm going to treat it as a chain rule because it's technically what it is. So if we use the chain rule here, we have an e to the something. So the derivative of e to, something is e to that something. It doesn't change, right? So we have e to the 0.0198t, but then remember that the chain rule says that we need to then take the derivative of that something, of that exponent. So we get 0.0198. And this actually reduces much nicer than you probably think it does. That turns out to 99 e to the 0.0198. Oh, Lord, I forgot to put a prime. It should be p prime, not regular old p. Since we took a derivative. And they just asked for the rate. And since this is the rate here is just an equation, they didn't ask us for the rate at a certain time. So the rate here is just this derivative equation. Just about either of those pieces. All right. The next thing we want is we want to find and interpret f of 5. And I forgot that I wasn't clear about naming those. So I probably should have put p and p prime, but I didn't when I wrote this. So I just mean the two equations that we're working. 0.01918. So we want to find both of those at 5 and interpret them. So I'm going to kind of split this up a little bit. So f of 5, well, to find f of prime and f prime of 5, those are just plug and chug questions, right? You just plug in 5 and plop that sucker in a calculator. 0.019 99 times 5. I've forgotten what these are, so we need to find them again. 5,000 times e to the... So our f of 5 is going to turn out to be approximately 5,520.33. And then our f prime turns out to be approximately 109.30. Again, since we're working with money here, let's just do just 2 decimal places and call it a day. So we want to interpret both of these. So the f of 5 is just an original function, so that's a time and an amount. So that's just saying 5 years, $5,520. So I would say something like after 5 years, balance is $5,520.33. You could say something like the balance is $5,520.33 after 5 years. In 5 years, the balance will be, as I've said a few times throughout the semester, as long as it gets the point across, as long as it's, at least general English. If you're using English words, you're good. It doesn't have to sound great. But then for interpreting the derivative, remember we kind of have two choices. So since this is kind of a review thing, I will, oh my Lord, I will write both. Let me try to write this a little smaller so I have more space. What is that? There we go. So remember there's two ways. There's essentially the rate way and the slope way. So I'll write both. Remember, there's always essentially three pieces to these derivative interpretations. And the first piece is that you always need to tell them when you start. You always need to remind them of the x value or the t value that the derivative was evaluated at. So since we were evaluating at 5, we need to say something like after 5 years. So after 5 years. And I'm going to start both of those like that, after 5 years. So if I'm going with the rate way, that's when I have to tell them, the next thing is to tell them whether it's increasing or decreasing. And then the last thing is it, by that derivative value? So is it increasing or decreasing? And then finish off with the derivative value. Since the derivative is positive here, it's going to be increasing. What is increasing? The amount of money in the account. So I'm going to say something like, I'm going to try to make it smaller because I'm running out of space. I'm going to say the balance. So after 5 years, the balance is increasing. Balance is increasing by that derivative value. And when you use the rate way, you have to use the actual units of the derivative. So remember, a derivative is a slope, so essentially a change in y over a change in x. So in this case, a change in dollars over change in years. So the units of that is going to be dollars. Well, let me put the dollars in front, and then I'll just say per year. You could, of course, write dollars as a word, but dollars per year. Whereas with the slope way, essentially the second thing is to always say you're increasing the x or t value by 1, and then the y values are increasing by your derivative value. So I would say something like after 5 years, for each additional year, the balance increases by $109.30. In this case, it's just dollars, because remember, the per year situation is kind of taken care of when you say for each additional year. So also, again, in terms of me asking you to write one of these, you would of course only have to write one of them. I would say be familiar with both versions. Say this was a multiple choice question and the answer was written in the slope way. If you're not at least familiar with the slope way and able to recognize that that is properly interpreted, then you could possibly get the question wrong. So when it comes down to you writing them for like a full response question, you would only have to write one version. Be a little familiar with both. Sorry, my voice is starting to get destroyed, so I'm gonna have to stop for a drink every once in a while. All right, so the last piece of this question that's gone over a lot of different topics is to estimate f of 7 and f of 4 without actually using the equation. So I know obviously we have the equation here, we could just plug in 7 and plug in 4, but that's not what I wanted to practice. What I wanted to practice is I wanted to remind us, so in the last question we have f of 5 and we have f prime of 5. I wanted to remind us that when we're given something like that, we're given an original value and a derivative value, we can use both of those together to estimate other values for the function. So if I want f of 7, I always have to start with the value that I know. So I only know f of 5. And so essentially we want to build up to f of 7. So remember, since the derivative essentially tells us for each additional, when we move up 1, so I want to go from 5 to 7, which is a jump in 2. So I want to add on 2 of the derivative values here. So the 5020 plus 109, 109, 109, 30. So 5520 plus 109, 30 will give us an estimate for f of 7 to be 5629, 63. So remember, it's starting at the spot that you know, and then essentially adding on however many derivative values you need to add on to get from the original value to the next value. Oh, Lord, I didn't multiply by 2. Yep, I didn't do that. That was dumb. Thank you. Times 2. Sorry, 5738. 93. I have to multiply the 109.3 by 2. I wrote it down. I just didn't actually do it in the calculation. And then if I want f of 4, we still need to start with f of 5. So remember, you always have to start with the thing you're actually given. So I don't care if I was even asking for f of 9. I would not use f of 7. I wouldn't use f of 7 with f of 4 either. You always have to use the one that you're actually given in the original statement of the problem. Now, I know I didn't originally state let f of 5 and f prime of 5, but since they were used in the other pieces, we're just pulling them anyway. Now, you need to tack on a certain amount of f primes. Now notice that 4 is less than 5, so instead of adding values, we need to subtract values. And the difference between 5 and 4 is only 1, so we only need to subtract 1. So we have our 5520. So we don't have to multiply it by anything this time. We just need to make sure that we're subtracting instead of adding. Oops. And that will give us 5,411 and 3 cents. I'll leave those exactly. Questions, concerns about anything in that question before we go on to a slightly different one? All right, moving on. Let's shift over to our cost, revenue, and profit functions. So a shoe company pays $3,000 every month for materials. Each shoe costs $25 to make, and they sell shoes for $75. Assuming the functions are linear, find the cost, revenue, and profit functions for the company for 1 month. So that 1 month is just saying that we don't need to take that 3,000 into consideration more than once. So cost, revenue, and profit. For review purposes, I'll kind of write a bit extra. So remember, cost is made up of the fixed plus the variable. Sometimes this is also called marginal. I kind of switch back and forth. So in this case, our fixed is the thing we're paying no matter what, which is the 3,000. And our variable here, since it's linear, is the $25 it costs to make them. So it'll be 25 times Q. Our revenue function in general is our price times quantity, which remember that's more often used like if you're given a demand or a supply function and asked to find revenue or something like that. That's when you kind of need to remember that revenue is price times quantity. But here, so they sell them for $75. So the price is 75 times the quantity Q. And then our profit function, which remember for some reason is written as pi of Q, is our revenue minus our cost. 75Q minus, remember to always put your cost function in parentheses so that you remember and properly distribute that negative, because this would become 50Q, 75 minus 25 minus 3,000. If you don't distribute the negative, you're wrong. If you don't distribute it correctly, you're also wrong. So be careful with that. Always tack your cost function in parentheses. Now we're asked to find the break-even point. So reminder, break-even point, there's essentially 2 things you can do to solve for that. You can either set regular profit equal to 0, 0, or you can set revenue equal to cost. they will find you the exact same number. Here, I'm personally going to pick revenue equals cost because I think that's more often used. So I'm just going to go ahead and do that way. So I'm going to have 75Q equals 3,000 plus 25Q. I forgot to slow down and write down the first thing. Oopsie daisy. Y'all, if I ever start going too fast, just yell at me in chat. It's fine. So I would subtract the 25 from both sides. Get 50Q equals 3,000. Which, if you think about setting the profit function equal to 0, the first thing you would probably do is add the 3,000 to both sides, which would get you right there anyway, which again is why it doesn't matter which way you do it. So we divide both sides by 50, and is that 60 or 600? My brains. 60. Okay. So we get Q is 60. Now, remember or be reminded that the break-even point is technically made up of two things, break-even quantity and the break-even price. So I've got the break-even quantity, I don't have the break-even price yet. And remember, I always want both. Even if I don't super duper specify, if it says break-even point, I want both. So here we want the break-even price, and to get the break-even price, reminder, we plug the Q value we just found into either revenue or cost, not profit. If you plug it into profit, you're going to get 0, which, yes, is technically, the profit they get when they break even. But what we usually mean by break even price is we want to know how much money did we have to put into this thing? How much money did we have to make before we break even? So that's going to be from the revenue or the cost. I always prefer to plug it into revenue because it's usually the simpler function. But you can plug it into cost. It'll get you the same number. That's kind of the point, is that they're equal at that point. So we get $4,500 as our break-even price. So if you wanted units here, this would technically be pairs of shoes. And $8. Any questions, concerns about that one before we do another cost? Okay. So the next one has a rival shoe company. Finds that their revenue function is going. Now I used X's here instead of Q's because I wasn't thinking, but it's going to. So rival shoe company finds that their revenue function is given by 2x squared plus 15x, and their marginal cost is given by 6x minus 35. They know that their fixed costs are $75. First thing we're asked for is the company's cost function. So reminder, marginal cost is the derivative of cost. So we're given the derivative, not the original one. So essentially, if we know that the derivative of cost, and I should hold on for a second so people can write down the main points of this question, like 10 seconds. So if we want to find the original from this, we essentially need the antiderivative. So we need to find the antiderivative. So that 6 comes along for the ride. And now jump back from your derivative brain to your antiderivative brain. Add 1 to the power, divide by the new power. Antiderivative of constant is a constant times the variable. Now, usually we would tack a plus c at the end. Since the function name is c, I'm going to say plus k. Same exact thing, just plus a constant. If you want to put a c there, I won't, make a fuss about it. But I personally, since the function name is c, I would make that something else. So we have 3x squared minus 35x plus k. So we essentially need to still know what that k value is. We're told that fixed costs are $75, which means that c of 0 is 75. Now, you might realize that that's just going to go in for k, but in case you didn't, or in case they gave you a different value, say they didn't give you the fixed cost, say they just said they know the cost, total cost of 5 is 1,000, then you would plug plug in 5 and set it equal to 1,000. So let me do the full way here. So we would plug in 0 and set it equal to 75. Now, since this is a polynomial, those first two things are 0, and we do just get that k is 75. If you jumped to that on the final exam and just said fixed cost 75, k equals 75, and didn't show that extra piece, that's perfect. But just know that it's not always just the k value, or c if you're using the usual letter. So our full cost function is 3x squared minus 35x plus 7. So now we're asked to find the production level that yields maximum profit, and then what the actual maximum profit is. So this is the question we just did was like chapter 6 material. Now we're jumping to chapter 4. I will say that in terms of these in terms of questions that I put on the final, I do a lot of stuff like this where I will ask one question with multiple parts, and there's just like a ton of stuff, ton of different topics in the parts. But anyway, so we want to maximize profit. So the first thing we should actually find is profit. Although, well, let me say something first. So whenever you want to maximize or minimize something, remember that's when you want to find the derivative and set it equal to 0 to find the critical points. Specifically in terms of cost, revenue, and profit, remember that there's kind of a different way we can do that. Since the derivative, marginal profit is equal to marginal revenue minus marginal cost. Remember that you kind of have a second choice here of just setting marginal revenue equal to marginal cost. And that will find your critical points. So maybe I should even say to find crit points. That's just kind of review purposes. I'm personally going to go the find the derivative of profit way, because we're going to need the profit function at the end anyway to actually find the maximum profit. So why don't we go ahead and just find the profit function, find its derivative, and go from there. So regular profit, revenue minus cost. So we'll have revenue function was given as 2x squared plus 15x. Cost we just found. Put the cost function in parentheses or else you get it wrong. Space over there. So we've got the 2x squared minus 3x squared. It's going to give us negative x squared. 15x plus 35x, because you'll distribute the negative. So 15x plus 35x will give us 50x, if I'm not mistaken. 15 plus 35. Yeah. And then distribute the negative to the 75, you'll get minus 75. Oh, right. So now we have our regular profit function, so we'll keep that in our back pocket. We don't need that quite yet, though, but we do need its derivative. Don't need its derivative. So switch back to your derivative brain. Bring the power down. Subtract 1 from the power. Derivative of a constant times x is just that constant. Whoops, whoops. To find where something is a max or a min, you want to set the derivative equal to 0. So we're going to set this, what am I doing? Equal to 0. I would add the 2x over to the other side, and then to divide by 2. That gets us our critical point of 25. So here, this is technically a global max or min profit question. We want to know the actual full maximum profit. We don't care about local ones. If it gets maximums more than once, we want the actual full maximum. So for global max and min questions, remember we have to work on an interval. So the interval isn't explicitly stated here, so we kind of have to find it. So if we think about what these x values could be, well, x's are essentially the amount of items they're making. I think we're talking about pairs of shoes again. So what's the smallest amount of pairs of shoes they could make? Well, they could make nothing. They could make 0 pairs of shoes. but they can't make negative pairs of shoes. But then from there, they could make as many as they want. And so then the next thing to remember, I know I'm saying remember a lot, is that when you have a global max-min question and there's an infinity in your interval, that's when you need a number line. If you don't have an infinity, that's when you take your endpoints and your critical points and plug them into the original function and compare the y values. But here, since we have an infinity, we're going to need a number line. And the number line is going to be the derivative number line. So I'm going to cut it off at 0, put my critical point of 25 on there. And then we need our test points. That's real thick. So I'm going to pick 1 and 30 because I want to. Remember, it doesn't matter what number you pick as long as it's in that interval piece. And we plug that into the derivative, so we'll find pi prime of 1 and pi prime of 30. So we'll have -2 plus 50 gives us positive 48 for x equals 1. 2 times 30 is 60, so -60 plus 50 will give us -10, so a negative value for 30. Now remember, the point of this is that since there's an infinity, we need to make sure that global maxes and mins can actually exist. So we need to kind of figure out what the shape of the graph looks like. Is it going upwards forever? Is it going downwards forever? Is it going one way in one direction, one way in the other direction? So when we do this, remember the relationship between the derivative and the original function. If the derivative is positive, the original function is increasing. If the derivative is negative, the original function is decreasing. So that essentially means that we're going down in both directions forever. So that means that there can be a global max. We weren't asked about minimums, but if we were, there wouldn't be global minimums because it goes downward forever. But since it goes downward forever in both directions, that means that it must achieve a max somewhere. And where is it going to achieve that max? Well, it must then achieve that max at a local max. This is the only local max we have, so it's got to be there. So we have a global max at x equals 25. And we were asked for the actual profit level, which is the actual profit, sorry, which is good because usually you want the y value as well in these global ones. So we'll plug 25 back into the original profit function. And what is that? -25 squared plus 50 times 25 minus 75 is 550. So they don't make a ton of profit even when they're maxed out. But their maximum profit is when they sell 25 pairs of shoes. Their maximum profit is $550. Questions, concerns about that one? All right, got 25 more minutes. I've got 2 more questions with multiple parts. We'll probably get through 1 more question. And then I'll just post the answers for the last one on Blackboard for anyone who wants to look at it later. But here's our next question. So actually, this one's also max and min. So actually, maybe I'll go to this one. Let's go to this one. Since we kind of just did a max min one, the other one gets into a bit more detail because it does local, inflection, and global. Let's do this one since we've already semi-refreshed our max min brains. So I'll let y'all write that down really quick if you need to write it down really quick. Like 10 seconds. So this is kind of stuff that we've been doing the most recently. That was bad English. Most recently. So it should be a bit more fresh in your brains, hopefully. But anyway, So the first thing we want to do is we're considering the function 4x cubed minus 12x squared minus 16x. So the first thing we want to do is find capital F, so antiderivative, excuse me, if f of 0 is 5. Oh my goodness, now I've got the hiccups, great. The first thing we need is the general antiderivative. So that 4 comes along for the ride, add 1 to the power, divide by the new power. Minus 12 comes along for the ride, add 1 to the power, divide by the new power. Minus 16 comes along for the ride, add 1 to the power, divide by the new power, plus c. If we want to clean that up a little bit with our constants, I would definitely suggest it in this case. Would be x to the 4th minus 4x cubed. 16 divided by 2 is 8x squared plus c. And then we're told if we plug in 0. So again, in this case, since it's a polynomial, it does turn out to just give us the c value, but you should always kind of triple check because sometimes it doesn't, especially if it's not a polynomial. So since it's a polynomial, those 3 terms go to 0 when we plug in 0, so we'll get c is 5. So the specific antiderivative we want, x to the 4th minus 4x cubed minus 8x squared, that's 5. For the next piece, we're asked to calculate the integral from 0 to 3 by hand, so don't just type it into a calculator. So the first thing you would have to do is find the antiderivative. We already found the antiderivative. We're going to use the generic plus c one. But we've already found the antiderivative, so let's just write that down. So here was our antiderivative. And we want to go from 0 to 3. So remember, the point of doing these, well, not the point, the way you finish these by hand is to then take that top bound and plug it in everywhere you see an x. And then subtract. I always like to put it in brackets. Put it in something, parentheses, brackets, whatever floats your boat. What you get when you plug in 0. The c's always end up canceling each other out, which is nice. And actually that back piece is just going to be 0. So really the main thing we need to worry about is this front piece. So 3 to the 4th, 81. 4 times 3 cubed, 108. 8 times 3 squared, 72. And I'll just put in minus 0 to clear. Good, negative 99. Now remember, in terms of an integral in general, it's okay for it to be negative. Remember, it's just that means that there's more area underneath the function. Sorry, underneath the x-axis than there is above the x-axis. Maybe all of the area is below the x-axis. I don't know because I don't know what the graph looks like. But it's okay for a general integral to be negative. So then the last thing we're asked in this question, actually no, there's, yeah, there were 2 more. The next thing we're asked is to find the total area between the function. So let me remind us of the original function. Bring it down here. X cubed minus 12. Okay, scroll back down. So we want to find the total area between that function and the x-axis. So this is where we have to, find where they intersect, possibly split up the interval, find the top versus bottom in each case. So this is, our kind of long process that we just finished learning about. So let's, we've got kind of 2 of these, and then we'll probably be out of time. So since this is between the function and the x-axis, we're doing everything in terms of y equals 0. So we're taking this function, and since we want to set it equal to the second function, in this case, we're setting it equal to 0. All of those terms on the left have something in common. They have a 4 and an x. So we can go ahead and pull that out. If we want to start setting this equal to 0, that's going to be most helpful. And then that polynomial is factorable. Otherwise, you could use the quadratic formula, always. So we need two numbers that multiply to -4 and add to -3. So we'll get -4 and +1. So this will break up into x minus 4, x plus 1. So if we want to set that equal to 0, now that we have a bunch of pieces, we just set each piece equal to 0. We'll get 0, 4, and -1. All of those are in our interval. Now 4 is technically an endpoint, but so all of those are in our interval, so we need to consider them all. So we're going to need to split this up a couple times. So we're going on -2 to 4, so we need to include that entire interval. So we need to first split it up at -1, so we're going to go from -2 to -1. And then from -1 to 0, and then from 0 to 4. Now we need to find the top versus bottom before we are able to write our integrals. So if we do that algebraically, I'll do it both ways as I usually did. We need a number between -2 and -1. So this one is kind of gross. We need to pick some gross numbers. I'll pick -1/2, -1.5, then -1/2 between -1 and 0, and then, I don't know, 1. So at this point, remember, if you're doing it algebraically, you plug that number into both functions. Well, the one function is y equals 0, which is just always going to give us 0. In all of these cases, we'll get a 0 for the one function. And then I'm just going to write f so that I don't run out of space. Oops. And since we're running a little low on time, R is a bunch of calculators. Find answers. We've got taking longer than if I just punched my calculator. All right, we've got -16.5 for -1.5 when we plug it in. We've got +4.5 when we plug in -0.5. We've got -24 when we plug in 1 into the function 4x cubed minus 12x squared minus 16. So which function is larger in each case? We've got the 0 is the larger value, then 4.5, and then 0. If you were to do this graphically, where can I fit that? Try to squeeze it down here a little bit. This is obviously not going to be a scale because I'm squeezing it in there, but this would kind of look like this. This is 4, this is -1. So we'd have, nope. Sorry, I was looking at the wrong piece of my answer key. Oosh. Oosh. This is the -2 is like out here. So we've got that the x-axis is on top between -2 and -1, then the function is on top, and then the x-axis again, which is exactly what the algebra way just told us. So now we've got to find our integrals. So we've got an integral from -2 to -1, and if I'm not careful, I'm going to run out of space. Top function is 0 minus our bottom function. Always put the bottom function in parentheses to make sure you're not going to get the wrong answer. And then we've got an integral from -1 to 0. But now our top function is f of x. 4x cubed minus 12x minus 16x minus 0. And then our last integral from 0 to 4, 0 is on top again, so we have 0 minus the function. the dx squeezed at the very back there. Remember, in terms of these, at this point, you can punch these into a calculator. Also remember, since your final is open resource, even if you don't have a calculator that can do these, desmos.com, just type that in. If you need an integral symbol, you just type in INT and it changes it to an integral symbol. Of course, there are thousands of other things online that can do integrals, so you can just punch that in. You'll get 19, 3, and 128, hopefully, for a grand total of 150. Questions, concerns about that? All right. We'll do this last one, and then it'll be the last one. I'll wait a couple more seconds in case people are still ready to sit down or want to write the next one. All right. So for this last one that we'll have time for, we want the area bounded by the function. So still the 4x cubed minus 12x squared minus 16x. But now we're given a different function. So we're going to compare it to 8x minus 32 on the interval 0 to 4. So it starts off well, not exactly, but very similarly, where we're going to set these two equations equal to each other. I would personally bring everything over to one side. So if we subtract 8x, we'll get 24x, and then plus 32. Now this is a cubic that is not factorable, I believe. I don't think so. I was trying to do something in my brain. No, I don't think that's factorable, or at least not a way that I can think of off the top of my head. So what you would want to do with this, I mean, you could pull a 4 out of everything, but it's not going to help anything at all. So you could pull a 4 out. But here, essentially, what you would need to do is you need to use your calculator. Or you could also just use this in your calculator as well. We did one in class where we set two functions equal to each other in our calculator. So you could go from the original piece. Also, again, since this is an open resource exam, there's plenty of websites, wolframalpha.com. If you want to jot that down. Wolfram Alpha can do almost any math you throw at it. So you could literally write, calculate 4x cubed minus 12x squared minus 32 and just hit enter and it'll tell you the answer. So Wolfram Alpha could do this for you as well. So I'll leave that up for a couple more seconds in case you want to jot that down. But essentially the points where they intersect will be -2, 1, and 4 with whatever device you use to solve that. Note that the -2 is outside the interval. So we're not going to use that. We are going to use 1, and 4 is an endpoint already, so we kind of don't care about it. But it is kind of a note that it is in our interval technically. A little bit longer. So we need to split this up at 1. So if we pick pick numbers in those intervals, I'll pick 1 half and 2. Plug it into both functions. So we've got 8x minus 32 versus, I'm just going to write f of x again so I don't run out of space. And make my arrows look less dumb. So if we plug in 0.5 to 8x minus 32, we'll get negative 28. And then if we plug it into the 4x cubed function, we'll get negative 10.5. Whereas if we plug in 2, we'll get negative 16 and then negative 48. And if we were to do this graphically, this is where the graph started drawing from. Okay. So if we're starting at 0, the f of x function is on top in the first interval, which is what we get from the algebraic way. And then the 8x minus 32 is on top. So our integrals are from 0 to 1. Our top function is the 4x cubed thing, so we'll have 4x minus 12x squared minus 16x minus, in parentheses, 8x minus 32 to make sure it's done correctly. Integral from 1 to 4 of 8x minus 32 minus our 4x. Ran out of space. At this point, again, calculator website. Again, Desmos is pretty nice for these ones. It's kind of easy to, if you just type in INT, you'll set it up and just put it in. Again, Wolfram Alpha could do this pretty easily, although you probably want to type in something like integral of the integrand from 0 to 1 or 1 to 4, whatever you were doing. So Wolfram Alpha, if you're typing it in, it's usually just easy enough to do it in words, besides equations. Whereas something like Desmos, you'd have to use the symbols. But for the sake of time, I'll just tell us what these are. 1781. Maybe if you're not used to doing these in a calculator or anything, maybe you should take some time to practice over a little bit. So now that you know that there should be 17 and 81, maybe making sure that when you type that in, that's what you get. That might be a good idea. So we're a little early, but I think we've done enough. And I don't think we have enough time to really get through much of that other problem anyway. So are there questions, concerns on this one? Okay. Again, the only other thing, so I'll write the answers out to this before I post it. But this was the only thing we didn't get to. Again, we did kind of do a maximum minimum problem for the profit. But I'll write the answers out to that on Blackboard. There's a blank copy up if you want to try it before looking at the answers. Again, this isn't the official final exam review. That's up on Blackboard under the exam folder. Answers for that will be up ASAP. Just reiterate, if you want your exam 3 back, just let me know. I'll scan it to you. Email. Otherwise, I'll put that office hour information up on Blackboard. Other than that, you've got your homework on Thursday, your final on Tuesday, and that's it. So if you don't have any questions on your final or anything, I will probably not talk to you again. So thanks for a lovely semester. I know this semester was definitely not a usual one. I definitely got things went weird. So thanks for sticking with me. And otherwise, if you have some questions, feel free to stick around. Otherwise, have a great day. Study well. Let me know if I can help with anything. And I hope the rest of your semester is as least stressful as it can be.